The pressure switch. Why is it there? How does it work? And how do we check it? That's what we need to know today. The sequence of operation thermostat calls for heat. Sends 20 volts to IFC. The IFC does a safety check. The IFC closes a relay, sends 120 volts to our inducer fan motor. Our inducer fan motor pulls a draft through the heat exchanger. It also pulls a draft or pulls a vacuum to our pressure switch. Our pressure switch closes, sends 20 volts to the IFC. It's essential that we have this motor working, and we don't just want to assume that it's working. We need to know without a shadow of a doubt it's working, and that's why our pressure switch comes into place. Our control board just sends a relay, closes the relay, sends the voltage to this inducer fan motor to work, but it doesn't know if it's doing its job. What we have here is our vacuum pressure switch. As this motor's running, as it's pulling a draft through the heat exchanger, it's also pulling a vacuum to the switch. The switch closes, 24 volts goes back to the IFC. We know for sure that this motor is working. In the old days, they had centrifugal switches on these motors. So when the motor spun fast enough, the switch would close. The problem we had was these old motors would rust out. There'd be some kind of an issue with it. The switch would close, but it wasn't actually pulling a draft. The flame would roll out of the heat exchanger and catch the system on fire. So this was the better system that was invented. As this motor is pulling a draft, doing its job, it pulls a vacuum to this pressure switch, switch closes, tells the IFC it's working. So my students, to make them understand, I have them say it as a negative pressure switch or a vacuum pressure switch, so they understood that it's sucking, it's pulling a draft against the switch. It's also its job is to watch this motor, so to speak, to make sure it's doing its job. If this motor stops working, it tells the IFC, hey, we got a problem, and the IFC shuts everything off to make sure we're running safe. So some of my students, they call it a vacuum pressure snitch because its job is to watch him and snitch on if there's a problem. However you need to remember that, it's a massively important safety feature. So how it works is quite simple. Inside, there's a type of diaphragm in there, and there's also a micro switch on one side. So when we pull a pressure difference on one side, the atmospheric pressure pushes on the other. What it does is makes the switch close. It physically moves the contact with this piece here. But if we see this diaphragm fitting is very fragile, it's very thin type of material, so it's very easy to break. Over time, they can break or get worn out. They can crack, they become brittle, especially if you have condensation in there, which you shouldn't have. That can build up in here and cause severe problems with these. It's important that when you're checking this, you don't put your mouth to that tube and suck on it. I've seen people that check them like that, but the problem is you pull too hard and it does what happens to this one. It actually rips this diaphragm. The other thing is you have combustion gases through here, poisonous gases through here, and you don't know what's inside of this switch. So as you're sucking on that, you're pulling all that stuff into your lungs. So it's not a good idea to use that. We want to check it the proper way. So let's talk about checking it the proper way. This switch, we need to think about it as a pressure and a switch. So we need to make sure, do we have the proper vacuum coming to the switch first? Then if we do, let's see if the switch closes. So we're going to fire this system up and go through that process. But how are we going to check to make sure we have that happening? What we're going to use is this nice little brass tee. I'm going to unplug the hose existing, and I'm going to connect it to my brass tee. The other hose on the side is going to go back to my inducer fan motor, my inducer draft, so it's pulling a vacuum. That's also going to pull a vacuum to this and this third hose. In the old days, we used to use a magnet helix. I would use the low pressure side, and as this ran, I could see how much of a vacuum it's pulling in inches of water column on this tool. The problem with this tool is, over time, they get out of calibration, you gotta have them recalibrated, and they bounce around in a truck, and it would make them inaccurate. So now we have digital manometers. This is the way to go now. We simply plug this in, and if I want to calibrate it, I just press the 0 button, it zeroes it out, and I'm ready to start. So what we're going to start with is see, is the switch good? Is it bad? Are we getting enough vacuum? My control board, the switch, is it closing? What's happening? Let's find out. We're going to have a call for heat and go through our sequence of operation. Now our inducer fan motor is working, but we're pulling 0.1 inches of water column. This switch is rated at 0.25 inches of water column. So the switch right now is not going to close because I do not have enough vacuum going to it. 0.10. The switch should be open, which means I should read voltage. Let's check. I'm reading 27 volts, so I know my switch is open, and it should be open. You could think, well, the switch isn't closing and I want it to close, let's replace the switch. That would be wrong. That's like saying your gas gauge is on E, I need to get a new gas gauge. Do you have gas in the car? In this case, we need to be thinking, my switch isn't closing, it's a vacuum pressure switch. Do I have enough vacuum? And the answer is no. I only got 0.1 inches of water column. In this case, it's jumping around a little bit, but 0.1 inches of water column. I need 0.25 inches of water column for this to close. So I need to be looking on the fan side. What's going on here? Let me check that inducer fan motor, go through all the process to make sure that's working first. It's not a problem with my switch. It's on this side. So I want to make a minor adjustment to this unit. Now we can see I'm pulling 0.34 inches of water column. It closes at 0.25. There's two ways I can now see if that's working. One way is I can look down and see if my hot surface igniter starts getting hot. The other thing I can do is check voltage. With the switch closed, I should have 0 volts. Put the meter on one side and then the other, I'm showing 0 volts. So the switch is now closed, and down below our hot surface igniter is getting hot. So we know that that can't happen until the switch closes. So that's a good sign. As I cycle the system off, my inducer fan motor cycles down and I start losing my vacuum. The switch then goes back to its open position. It knows that it should be open. The control board knows that it should be open. Everything is working correctly, as it should. That's one way to check the switch. There is, however, another way to check it. What we can do is we can pull these wires loose. And I can have a call for heat. And with my manometer, I know I'm pulling the proper vacuum. I can then take my meter and turn it to ohms. OL, infinite resistance, open. And if I touch the terminals together, I got 0 resistance, closed. If I check across the switch, I'm showing 0 ohms of resistance. My switch is closed. If I shut my fan motor off, I lose my vacuum, the switch will close. So if we check the resistance now, we show OL, the switch is open. Two different ways of checking the switch. I prefer the voltage method because it's faster. I don't have to pull wires loose or worry about wires connections going bad. There is a third way of checking this. This particular model of manometer has a pump built into it. So what we're going to do is we're going to set that up next. I'm going to take this hose and the T off. We're going to put these adapters on. I put one hose on pressure port 1 and one hose on the pump. Then we're going to put an electrical connector adapter on the very end. This cord just has 2 plugs. We plug one into one side of our pressure switch and one into the other side. Now what I'm going to do is turn the pump on for test mode. So I press test. It's going to do a 13-second countdown. At the end of that countdown, I'm going to then hook up the T to my vacuum pressure switch. I'm going to then increase the pressure until my switch closes. Here there's a little word that says close and a light above it. Once this light goes off, we know that that switch is without a doubt closed. Right now we have 0 inches of water column, and I'm going to plug my pressure switch into this T. So here I have 0.1 inches of water column. The light is off. So I'm going to increase my pressure. So I'm going to press the up button, INC, increase. Now I'm at, we got to make sure we're not kinked. My hose is kinked there. So we're at 0.2 and my switch is still open. So we're going to increase it even more. And now we're at 0.25 and my switch closed. So know that my switch is good. It closed at 0.25 inches of water column, and that's what the switch is designed for. So my switch is working 100% correct. So it's another way of checking the pressure switches. Now most of these pressure switches are NO. NO stands for normally open. So if I check these two, they're normally OL, infinite resistance. If I check it on the unit, I have 24 volts or some kind of voltage. But not all of them are normally open. They do make some that have normally open and normally closed connections, such as this one. The control board for this particular unit to know that the switch is for sure closed and the switch is for sure open. In other words, right now the system is off. It wants to know that that switch is closed, and when the system came on and pulled the proper vacuum, the normally closed would open, the normally open would then close. Without a doubt, the control board would know that this switch hasn't been bypassed. I have seen people try to bypass these, and you never want to do that. At the end of this video, we're going to show you what happens if this motor is to fail and it was to be bypassed and how dangerous that can be. So you never want to bypass that. I prefer to always go back with the manufacturer's OEM pressure switch, but nowadays I hear that they do make a universal kit that you can adjust and change the springs to match exactly what's here. But if you use that, you must make sure that you put the exact amount of pressure. This one closes at 0.25. I want to make sure without a doubt that my new one closes at 0.25. The other thing you want to check is these hoses. The hoses that connect it become brittle over time. They can be cracked, they can pull air in, and that air can make the switch not get a good seal. So you want to check this, and also sometimes this little tube where it connects into this inducer draft can clog up with rust or other contaminants. So you want to make sure that's in good shape. I used to keep extra hoses with me just in case that they cracked or broke. I can replace them and not have to worry about it. So just to recap, it's a safety device that makes sure this fan motor is working. Most of them are normally open. They close when we have the proper vacuum. To test it, the method I prefer is a T and a manometer, and check to see if the switch is open or closed with voltage. If I'm reading 24 volts, the switch is open. If I'm reading 0 volts, the switch closed. Very simple. Don't suck on it. Don't pull too much pressure on it. You don't want to damage it. And if you have to replace it, go back to make sure it has the exact same inches of water column that it closes for.